Manager for the National Center for Rural Road Safety. Today's webinar will be on the primer on the joint use of the Highway Safety Manual and the Human Factors Guidelines for road systems, using human factors to guide data-driven decision-making. And so we're going to get started now, and I'm going to end these polls and give you a few bits of information about who's joining us today. It looks like we have about 32% of you from the Midwest, 20% from the Northeast, then about 18% from both the Southeast and the West, 9% from other. We also have most of you, as always, joining us by yourself, but we do have a few in groups, and I'll go over some instructions for those of you in groups when we get to the next set of slides. It also looks like we have about 42% of you this time from state DOTs, about 23% from local DOT, and 11% are federal DOT. And we have about 4% education, 9% consultant, and about 6% from other local government agencies. And most of you are joining us today by computer only. As always, I will let you know that the phone number is in the top left corner. If you do experience any audio issues, we would recommend that you call in on the phone, as sometimes it is just the computer audio that has some issues. Also, if you are joining us by both computer and phone, we'll remind you to please mute your computer speakers. Otherwise, you will hear some feedback on your phone. So I will move us over to our presentation at this time. Today is going to be presented by John Campbell of Battelle, but we do also want to mention just a few other contributors to the project. John Milton from Washington State DOT, Sam Tignor from Virginia Tech, and Alexander Maestros from Cambridge Systematics. So just making sure to give them the proper credit they deserve. Some logistics for today. Our webinar will be an hour and a half long. It is being recorded and will be available on our website within the week. We will also send everyone who registered an email letting you know when that link is available. For quality of our recording, as I've mentioned, your phone line will be muted during the presentation. For those of you who joined us earlier when we said you were unmuted, we have fixed that, so everyone is now muted again. If you are listening on the phone, please mute your computer. To maximize the presentation on your screen, there are 4 arrow keys that press outward in the top right of the presentation. You will most likely want to use this later in the presentation, as there are several tables that will look a little small if you're on a laptop, so maximizing the screen may be a better way to view those. At the end of each section today, we will have time for question and answers for our presenter. There's also a handout pod in the bottom left hand of your screen. This has for you the Human Factors Guide report. It also has a handout for today's presentation to be used specifically during the examples that will be done in the last section of the presentation, as well as the PDF version of all of the slides from the presentation as well. For those of you who I mentioned were joining us in groups, if you could send the group list to info@ruralsafetycenter.org, that will help us be able to send everyone the survey. The survey is how you'll be able to select to receive certificates of completion and CEUs for today's webinar. So again, we would need names and email addresses for everyone who is attending in a group. And lastly, we will have 2 follow-up surveys. The first one will come directly following today's webinar, and that will ask you questions about the topic and the presenter and how you heard about our webinars. The next survey will come in about 3 months. That one will ask you more direct questions about what you learned in today's webinar and how you've used that information since. So perhaps you've gone and followed up and looked at the primer or put it into use at your company. I did want to give a little bit more information about our certificates of completion and CEUs because we did receive a lot of questions following the January webinar. The survey link for today's webinar is now found on your screen. I will also place that in the chat pod. I wanted to make sure that everyone has that right now. It will be emailed out to you after today's webinar, but we did have a lot of people who never received it or it ended up in their junk mail. So I do want to provide that to you as well. You'll only be able to fill this out once, whether it's through this link or through the email that you will receive, but it will not let you fill it out twice. The survey closes 2 weeks after our webinar, so 2 weeks from today. You can expect your certificate or CEU form 3 to 4 weeks after today, as I can't start creating them until we close that survey. The CEU form needs to be returned to continuinged@montana.edu. It does mention that right on the form itself in the top right-hand corner. The Continuing Ed Department at Montana State University is who provides those CEUs for you. And you are able to request a verification of completion form, and I'll show you that on the next screen. It will show you every single one that you have asked for CEUs for, and that's what you would turn in for any licensing boards. The certificate you can see on the screen right here is manually created by us after each webinar, so that's why it does take a few weeks for you to receive it. We manually create those and email them out to each person individually. The course registration form is the one on the left. I send that out with the certificates, and again, you fill that out and send it into Montana State. There is no fee for this. The Safety Center has already paid that fee for you. The verification form is the one on the bottom right. It will tell you the ID number for Montana State, along with what webinar and how many CEUs you have received. Please remember that a CEU is different from a professional development hour or PDH. So they add up to 1, so 1 CEU equals 10 PDHs, usually for a licensing board, but you will want to check your own state to make sure that this is true in your state. Today's presenter is John Campbell from Battelle. He is the research leader for the Center for Human Performance and Safety at Battelle. He is responsible for leading programs and conducting research in the area of transportation, human factors, and driver safety. He leads Battelle's Center for Human Performance and Safety in Seattle, Washington, a team of behavioral scientists and engineers that provide a human-centered approach to the development and evaluation of transportation programs, products, and systems. Dr. Campbell has conducted numerous research studies involving driver behavior, vehicle safety, and driver assistance systems, using on-the-road vehicles, driving simulators, and test tracks. Since 2005, he and his colleagues have been developing the Human Factors Guidelines for road systems on behalf of the Transportation Research Board. That HFG is the one I mentioned that you can download out of the handout section in the bottom left-hand corner. The 3rd edition of the HFG is currently under development, and once that is finished, John has promised to let us know, and we will send an email out to everyone on this distribution list who registered for today's webinar to let you know when that 3rd edition does come out. Before I move over to letting John start, we do have a few poll questions for you guys. John would like to know if you've ever used the Highway Safety Manual. Yes, no, you're familiar with it but have not used it, or not applicable. And the same thing with the Human Factors Guide. You have used it, have not, you're familiar with it but have not used it, or not applicable. We'll just give you a few seconds to fill those out. Okay, perfect. So John, for purposes of your presentation today, it does look like about 58% have used the Highway Safety Manual, and about 28% are familiar with it but have not used it. And only about 10% of people have not used it at all. And then for the Human Factors Guide, the numbers differ greatly from that. So about 14% have used it, 17% are familiar with it but have not used it, and about 65% have not. So today's webinar should help that group of people who have not heard of it yet learn a little bit more, become more familiar with it. The goal of today's webinar is once you've completed the webinar, you'll have an overview of the primer on the joint use of the Highway Safety Manual and the Human Factors Guideline for road systems. And we have 3 learning outcomes for you today. We hope you'll be able to summarize the role of human factors in roadway design, operations, and safety. Secondly, to incorporate the HFG and the HSM into the data-driven decision-making process And thirdly, to illustrate how to use the HSM and the HFG together to improve decision making. So at this point, I am going to turn our presentation over to John.
Thanks, Jamie. Thanks for your help getting this set up, and thanks to all of you for taking the time to dial in. I hope that this will be useful for me, for all of you. I'm very pleased to see the results of the survey. I think the presentation that we've got today is geared just to the right audience and presents the right information. I've been developing the HFG since 2005, and more recently we've had the opportunity, in addition to updating the HFG, which is a separate effort, we've had the opportunity to put together a primer that talks about how to jointly use the HFG and the HSM to improve safety decisions. And so my talk today will walk through the basics of human factors and why they're important. I'll talk about the primer itself, how it's structured, what it contains, and then I'll walk through an example of the primer. As I said, the primer is not done yet. It'll be done probably in the next few months and published by NCHRP, and we'll send out a link so that you can all go get that. My background is as a human factors psychologist and as an expert in driver behavior, driver performance. So I'll spend a lot of time today talking about human factors and the HFG. I have less of a background in HSM, though I'll stumble through talking through the HSM, and I'm glad that all of you are, or it looks like most of you are well equipped and knowledgeable about the HSM. So let's go ahead and start with a little bit of introduction about human factors and why you should care about it. So human factors is the scientific discipline concerned with understanding interactions between people and systems. And it's a profession that applies theory and principles and data to system design in order to optimize well-being and overall performance. And when you think about human factors in the context of road safety performance, we're most concerned with the needs and capabilities and limitations of all road users as we go about planning and designing and operating roads, pedestrian bicycle facilities, vehicles, and as we look at identifying causal factors for conflicts and crashes. And that little figure there gives you a sense of, from a human factors perspective, how are we thinking about things? And we think about road users who sense things and process things and then have an effect on their environment. They're taking into account laws and procedures and rules of the road. And then the vehicle in the roadway also has displays and operations and controls that function as part of the larger environment. So we see road users as fitting into this larger system. And when we think about road user capabilities and limitations, and I'll use those words a lot as we're talking through today, there's a whole group of human information processing elements that we're thinking about. And it has to do with the sensations, the things that we see and hear and feel as road users, our perceptions, how we organize and make sense of the information around us. The attention that we give to actively process information at any point in time, the process we go through for making decisions and deciding how we're going to respond, and then executing that respond, actually taking actions, whether it's walking or bicycling or driving on the road. And then the notion of memory, our ability to retain and recall things. So all of these pieces are part of what we refer to as human information processing, and it's part of the capabilities and limitations that we're most concerned about as it impacts road users. So as we think about human factors and think about the human factors implications of safety and driving, there are three elements that we'll be concerned about. And these are also things that we'll talk about, and these are elements that are incorporated into the primer on the joint use of the HSM and the HFG. So we're looking at three components. The road user, it could be a driver, pedestrian, bicyclist, anybody who's on the roads, the vehicle itself, and then the roadway environment, which includes things like the built environment, of course, but also includes things like light levels and weather and things like that. And importantly, we want to think about these these components and their interdependencies. And so you have road users that control vehicles and sample information from the environment. You have an external environment that provides information to the road user and also responds to the driver through action. So as drivers take action, for example, other vehicles take action in response to the driver, or pedestrians and bicyclists respond to that driver. And then the vehicle triggers responses in the environment and, of course, provides feedback to the driver. So these three elements work with one another and, of course, are interdependent. So why is human factors important to roadway design and operations and safety? Applying human factors is about examining who is engaging in crashes, where they're crashing, and why they're crashing. A very important thing to keep in mind with human factors is that it's more than the overt specific behaviors that contribute to crashes. Things like speeding and impaired driving and road rage. Those are things that very commonly we think about as the constraints and the limits of human factors. But it really is much more than that, and it really includes relationships and capabilities between what is really required of a driving task or another kind of road user task at a particular location and under a specific set of circumstances, and what are the capabilities and limitations of the road user. And so as we think about and consider human factors, we want to think about it as more than just those specific behaviors, but think about it in the broader context as what the road user is capable of doing in the context of a particular driving situation at a particular location. So what is the HFG? What is the Human Factors Guidelines for Road Systems? As Jamie mentioned, that's that 14 megabyte download that you see over in the handout section. This is a resource for improving roadway safety performance that provides guidelines and data and insight on road user characteristics to help guide planning and design and operational decisions. There's a focus in the HFG on road user limits and capabilities, and the idea behind it is not to replace the judgment and experience of highway designers, but to augment it and aid it and help it. And the HFG focuses on presenting the best factual information and insights from the human factors literature. And it's intended to complement existing sources of road design information, things like the Green Book, the MUTCD, the HSM, other sources. It really is intended to be worked with and used side by side. The second edition of the HFG was published in 2012 as NCHRP Report 600. It's available as a PDF. It contains 90 distinct guideline topics. As I mentioned, it's fact-based. It's got almost 500 individual citations within the HFG. And there's also a training course that we developed to go along with it. I've given you the web link there, but as I said, the handout section has that PDF. And as Jamie mentioned, we are in the process of developing the third edition of the HFG with some expanded content. One unique feature of the HFG is the way that we present individual guidelines. As I mentioned, there are 90 individual guidelines in the HFG, and they span topics like sight distance, intersections, signs, markings, lighting, horizontal and vertical curves. There's about 15 technical chapters plus some tutorials and some front matter. But each individual guideline is presented using a consistent two-page format, where when you open the HFG up, you've got on the left-hand page a title and an introduction to the guideline. You've got the actual guideline itself is presented as precise and in as quantitative a form as possible. Then you've got some kind of figure or table or graphic. All of these are on the left-hand side. And then the right-hand side is sort of a miniature lit review where it walks through some of the key literature that form the basis for the guideline, has some discussion, has some trade-offs, and then has the key references that went into the guideline down on the lower portion of the right-hand page. So each guideline is intended to be self-sufficient and self-explanatory, and there are 90 guidelines in the document. Let's see, Jamie, is this something for you?
Thank you. At this point, we are going to stop and take questions. As always, questions can be asked via our chat pod on the left-hand side. We do have a poll question for y'all while we are waiting to see if anyone has questions for our speaker. The first question we have for you is, human factors only relates to specific driving behaviors that can lead to crashes, such as speeding, impaired driving, etc. Is this true or false? And again, the chat pod is over on the left-hand side if you do have any questions for our speaker. Okay. I have now closed the poll and broadcast those results for you, John.
Yeah, so the answer to that is false. The idea is that we want to think about human factors in a broader sense than just those behaviors that are unsafe, whether it's not using seat belts or driving distracted or driving under the influence of alcohol or speeding. We want to take a step back and think about human factors in the context of the broad capabilities and limitations of road users as they apply to driving in specific contexts and under specific circumstances.
Perfect. And we did have one question come in for you as well. That question is, does NCHRP 600 address the ways road users respond when the environment is too complex?
And the answer is yes. And we usually do so, thank you for the question, John. We usually do so in the context of specific kinds of design elements. And so there's a chapter on signs, and we talk about sign comprehension and limits on what people can comprehend. We talk about problems with too many signs. We also, there's a chapter on changeable message signs where we talk about the length of messages, frequency of messages where you've got phases. So the notion of complexity and driver overload is there's several places in the HFG that touch on that. That's a great question.
I think that's it for questions at this point, and I have moved you back to the presentation, so you're all set.
Thank you. So let's talk about incorporating the HFG and the HSM into the data-driven decision-making process. And what I'm going to do is I'm going to start out with an introduction to this primer that's under development. And keep in mind, we're still working on this, but it should be published and available through NCHRP in the next few months. So the HSM, as you all know, is used to quantify the effects of safety decision-making on crash frequency and severity outcomes, thus providing an estimate of the safety of roadway infrastructure. The HFG is used to facilitate safe decisions by providing the best factual information and insight on road user needs. And then together, the idea is that using both of these sources in conjunction with one another will improve your ability to select roadway design and operation elements based on the best available data. And what we've been trying to do is to build a document that can be used together that'll help use the HSM and HFG together to improve road safety performance. And overall, what we're trying to do is to facilitate the combined use of the HSM and the HFG. The primer is supposed to be a short, instructive, and easy-to-use document that explains how to use these two resources together and provides all of you with a tool to enhance data-driven decision-making. And there are really two pieces to the primer that's under development. One is a general step-by-step description of joint use, and I'll walk through those steps in just a moment. And then the other is a set of specific examples that illustrate how the HSM and the HFG could be used together. And in terms of kind of size and scope, the total document is about 100 pages long, and the description of the step-by-step approach, the joint process, is about 25 of those pages. And then the other 75 are a series of examples. So we've got examples for a rural two-lane, two-way road, a rural multi-lane highway. That's the example that I'll go through in a little bit. We've got an example on urban and suburban arterials, one on local streets, and one on signalized intersections. So 5 examples that really take up the bulk of the primer, and then a clear description of the actual process of how you use the HSM and the HFG together. So this is a diagram that explains that joint process. And if you go to the handout that you've got, this is also on the first page. The handout is primarily for the example that we'll walk through in a little bit, but the first page of the handout also has this figure. And the steps are really fairly straightforward for those of you that have been doing diagnostic assessments and using these kinds of tools. And I'll walk through them in more detail, but at a high level, step one is collecting site data, crash data and volume data on the actual site. Step two is reviewing the site and the existing conditions. Step three is identifying potential countermeasures. Four is developing further and prioritizing those countermeasures. And then step five is conducting a safety effectiveness assessment. And neither in this talk nor in the primer do we talk a lot about step five. That's really quantitatively assessing the safety performance change of the completed project, whether you're doing a before or after study or some other approach, but we wanted to include that step. So let's walk through each of these steps in a little bit more detail. So the objective of step one, collecting the site data, is to compile all the data necessary to assess the safety performance at the site quantitatively and qualitatively. And typically you're obtaining and organizing data on things like crashes and traffic volumes, any kind of recent projects, any upgrades that might be improving safety. Things to keep in mind are the scale of the data that you're collecting, the timeliness of the data, and any kind of limitations that might impact the quality of the data. And what you're really looking for at the end of step one is a time-structured collection of the crash and the traffic and any project data that thoroughly describe the safety and the behavioral and the roadway data that are relevant to the site under investigation. Step two is really kind of a situation assessment. You're looking at the site and the existing conditions, and you're trying to identify potential contributing factors to the crashes from both a traffic engineering perspective and a human factors perspective. And it's really important in this step to not kind of jump through to thinking about solutions. All of us are kind of geared and wired to seeing a certain set of crashes, a certain pattern in the crash data, and jumping to the solution, jumping to the countermeasure. And what this step tries to do is to encourage us to kind of take a step back and look really hard at the issues, looking at their not just factors but interactions across factors, and try to get a sense of what really could be going on, what really are the potential contributing factors. And so it includes conducting a site visit where you're looking at the various conditions there at the site, and it's more of a qualitative analysis of what's going on. You're looking at the crash patterns and trends and trying to get a sense of well, what is the safety performance at the site, and looking at mode or year or crash type or contributing factor, and looking at the data in different ways and through different lenses to try to put together more of a quantitative description of what might be the safety challenge at the site. And then conducting a human factors evaluation, and we've got some tools that I'll walk through for how to do this. What are the possible human factors issues that should be considered in developing robust science-based safety solutions? And the idea here is to try and identify issues that, if anything, are overly inclusive, as opposed to kind of very quickly trying to winnow things out or throw out ideas. It's to be expansive as you can in terms of what really could be going on here. And one of the key outcomes of this activity is what we call a human factors interaction matrix, and I'll describe what that looks like and how it works, that is populated with all possible road user, vehicle, and environmental issues, as well as their interactions that could be impacting the safety performance of the site that you're looking at. The next step is using the HSM and the HFG to identify countermeasures. And so here's where you've looked at the site, you've identified some potential issues, and now you're digging into those two resources to get a sense of what can be done about it. And so for the HSM, that involves using either Part C, the predictive method, or the CMS that are in Part D to estimate the effects, the outcomes of using various treatments or countermeasures. And the outcome here is a quantitative estimate of the potential impacts on crashes for each of the solutions that you're looking at. And then also do the sort of a parallel process using the HFG. And you're creating a list of HFG contents that correspond to potential contributing factors and countermeasures. So from the HSM, you want a succinct summary of those road user issues and specific recommendations and countermeasures from the HFG and any related information that will support a robust safety solution. And in this regard, the HFG includes not just specific solutions and countermeasures, but it also includes a great deal of broader discussion and trade-offs associated with different human factors issues and different kinds of countermeasures. So it can be a rich source of information about what's going on in addition to what you can do about it. And also in this step, there's a recommendation that maybe you need to do another site visit now that you've kind of gotten to this step of the process. So step 4 is then developing a prioritized list of potential countermeasures that will address those safety challenges and issues that you identified in step 2. So from the HSM, you're looking at the confidence and the benefits and the impacts and conflicts and feasibility of all the different countermeasures that you've been looking at for the HSM and sort of cataloging the strengths and weaknesses of each of those countermeasures. And you're doing the same thing with information that you get from the HFG. And then you're trying to synthesize and prioritize the countermeasures that you get. And some of the questions that you're asking yourself, what really is the alignment and the correspondence between the engineering solutions that you've come up with, the crash trends, and the contributing factors that you see both in terms of the HSM analysis and the HFG analysis? How do the recommendations from each source relate to or complement one another? And this is actually pretty critical. There's going to be countermeasures and solutions that you get from the HSM that you don't see in the HFG. There'll be countermeasures that you don't see in the HFG that you don't see in the HSM, and then there'll be some that overlap. And so we'll see that in the example that we walk through. But finally, ultimately, you're trying to answer the question, given the overall situation, the options that you have, the strengths and weaknesses of the various countermeasure options, the strength of the research record as it applies to those options, what seems to be the most feasible from a safety and an implementation and a cost perspective. And what you want to emerge with at this step is really a prioritized list of countermeasures that could be developed into actionable projects. And then finally, as I mentioned earlier, step 5 is conducting a safety effectiveness evaluation. We do not go into this step in any particular detail. There's some links that we've got there to the CMF clearinghouse. There's some recommendations there. There's Ezra Hauer's work. There's lots of work out there on before and after studies and how is it you go about actually assessing how well you've done in terms of making changes. But the idea here is that you have a solid, rigorous quantitative analysis of the effectiveness of the roadway changes based on the recommendations that you've adopted. So let me talk now and shift, and I'm going to kind of walk through in a little bit more detail using those 5 steps as really some guide points. How is it that you develop these countermeasures from the HFG perspective, and then we'll walk through how you do it from the HSM perspective, kind of in a generic high-level way, and then we'll dive into our example. So from the HFG, this is a figure from the Indiana study that Treat did back in '79. There's been a lot of recent studies, but the basic data haven't really changed. While drivers are contributing to 93, 94% of crashes, they're the sole cause of only 57% of those crashes. A great many crashes are caused through the interactions between road users, vehicle, and environment. It's not as simple as saying, drivers are causing 93% of the accidents. Very often, errors don't reflect the breakdown of a single factor, but really they reflect a confluence of factors that occur more or less simultaneously. You've got, an older driver driving at night with roads that perhaps aren't very well marked or roads that don't have a sufficient shoulder. You've got younger drivers who have lots and lots of signs, maybe too many signs that they've got to see and process at once, and they're incapable of doing so. And so as we're thinking about the relative role of road users and vehicles and environmental factors, we want to think about the full range of those factors that interact with one another, interact with a specific context, and lead to errors and crashes. And so we've kind of structured this general approach to conducting diagnostic assessments with the HFG. And it's really, there's a series of steps that are linked into the five-step process that I mentioned earlier. In step 2, we're identifying driver information needs or road user limitations that could lead to errors or problems or crashes. In step 2C, we're trying to dig a little deeper and identify, well, as we look at these issues, why really are they a problem? What are some of the outcomes that we might be seeing from these limitations? We're also looking at interactions across issues. And then what is the key information and countermeasures provided by the HFG in step 3B? And again, these steps I'm referring to are in that very first page of your handout, but we'll walk through them in our example. So I mentioned earlier the Human Factors Interaction Matrix. This is a tool that we've developed for identifying and cataloging road user, vehicle, and environmental issues as well as their interactions, and then corresponding sections in the HFG. There's nothing magical about this. It's just really a simple matrix. It's really just a modified Haddon matrix for most of you that are familiar with Haddon's work. But we use this starting in step 2 to help identify those factors that could be contributing. And as we work our way through an individual site or problem, this matrix is kind of sequentially completed, and we'll see some of that as we go through the example. So what are the kind of things that you want to be thinking about as you're populating this HFIM? This is a set of factors. It isn't. There's probably other kinds of things we could include there, but it's really intended to be a head start at thinking about the kind of factors, the kind of variables and issues that ought to be included in the road user, vehicle, and environmental columns in the HFIM. And so with respect to road user, we're concerned with the age of road users. Is there a preponderance of older or younger drivers? Are there any issues related to their capabilities that are important, or their levels of experience? Are there things that we know, maybe from the crash data, about impairment or specific kinds of behaviors that are important to thinking about safety at that site? When it comes to vehicles, it's more things like vehicle types, things like differences between motorcycles and heavy trucks in terms of what they can see from the roadway, maybe their ability to maneuver in the facility. What kind of safety features do the vehicles have? What about headlamps or any other kinds of distractions that could potentially be contributing to the safety performance of a facility? And then sort of the heavy hitter here is the environment. What do we know about posted speed, traffic volumes, flows, the widths of lanes and shoulders, sight distance, the presence of bicyclists or pedestrians? What is there in the way of transit stops, and where are they? What kind of signs do we have? What are some time of day issues that might be there at the facility? These are all the kind of things that you could use to start thinking and to help populate that HFIM in step 2. So the goal for using the HFIM, this matrix, is to consider and document the road user and environmental issues that could be contributing to problems at a site. And there's a couple of key inputs that you use as you're thinking about the matrix and as you're filling it out. One, of course, is just the basic crash or conflict data that you compiled in step 1. It also includes the site visit results from step 2A. You know, what are the types of vehicles you see, cross-section dimensions, traffic volume, speed limits, anything that you can glean from the site visit. And then finally, those crash data trends are very, very important. Looking at those trends, trying to isolate what really seem to be the heavy hitters in terms of crashes and how that fits into our thinking about human factors. And as I mentioned, the approach should be overly inclusive. The matrix at this stage in the process should include any factors or combinations of factors, and the interactions, of course, are very important, that could reasonably be contributing to known or suspected opportunities for improving safety. And again, identifying interactions is going to be crucial. How could combinations of relevant factors create confusion or distraction or uncertainties or misperceptions on the part of road users? And a great deal of what this requires is really serving as a virtual road user. And Sam Tigner talks a lot about this, of putting yourself, you the engineer, you the designer, you the planner, in the place of pedestrians and bicyclists or road users, and trying to think through, you know, where there's some possible areas of confusion, where is there some uncertainty, some mismatches between what's really going on in the environment and what a reasonable user might be thinking is going on. And here are some key questions, and I think I've got these also in the example piece, but here are some key questions associated with all of this that may help to kind of frame and structure the activities as you're putting together the HFIM. What really is the underlying nature of the crashes and conflicts that are observed at the site? What can the most common crash types tell us about the relative contribution of the road user and the vehicle and the environment at that site? Easy questions. What are the most common contributing factors that are cited in the crash record? Again, from the perspective of a road user, what might be some sources of confusion when the road user is trying to extract the most meaningful information from the road geometry and the traffic control information? What are some unique issues associated with vehicle type? I mentioned earlier trucks and motorcycles. Are there any things related to height or size of the vehicle that might be contributing to problems? Are there any unique environmental or road conditions that could cause stress or additional time to comprehend or unrealistic requirements for responding to the facility? Are there any clear or unclear or misleading cues between the roadway and the user? Is the roadway sort of telling the user one thing when really the user is supposed to be doing another? So thinking about the message that the roadway and the environment is presenting is helpful. And then it's important to consider not just the factors that were present sort of at the exact time and location of a crash, but also thinking about things that could have occurred prior to the crash. Very often, the problems that users experience started upstream of the crash. And so you want to be looking for causality, not just at the site itself and what you can see at the site, but what was happening maybe 50 or 100 yards before the site that could be contributing to confusion or misperception, because very often the problems that you get have happened a bit before the actual crash itself. So these are just some questions to kind of think through and work through as you're developing the HFIM. So we'll go into this in more detail, and this slide, there's a series of slides that I've got here that have a lot of dense information. That's why we put together the handout. But this is showing a partially completed HFIM for the rural multilane example that I'm going to go through in a little bit. And I'll just kind of walk through these at a very high level. You may not be able to read those on the screen, but again, they're in your handout. But from the road user perspective, there were speeding behaviors, there's some impairments due to alcohol or distraction, and there's a future increase that we see at that site in younger drivers. There's some glare from oncoming headlamps that could be contributing to some problems. In the environment itself, and again, you'll see this in the example, there's no median, no cables on the center median, there's no lighting at all, it's got a high posted speed, and again, there's future expansion of the site and future increases in traffic volumes. So then we've got some interactions that the lack of barriers could be contributing, combining with the high speeds to contribute to crashes and injuries. So we're seeing interactions between the environmental situation and some of the high posted speed. Lack of lighting could similarly be contributing to that. And then those high speed limits could be a problem with future younger drivers. So this is a partial example of what the HFIM might look like for the particular example that we're going to go through in a little bit. So then once you've got sort of I'll click back a little bit, once you've got kind of a basic sense of what's going on, and an actual HFIM might be much, much bigger than this, but you've established the basics of the situation, key factors related to crashes and their interactions. Then as far as the HFG goes, and I'll get to the HSM piece in a minute, but as far as the HFG goes, the idea is to create a list of contents in the HFG, particular chapters and guidelines and tutorials that correspond to those design issues or safety issues that you see. So using the results of the HFIM, you begin to generate a list of keywords that could be used to characterize the nature and cause of the crashes and related outcomes that you see at the site. So once you've developed that list of keywords, then you simply go through the HFG, you're reviewing the table of contents, you're reviewing the index to identify any chapters or guidelines or tutorials that are broadly, generally relevant to those interactions and the underlying safety issues. And then once you've got that list, you go through and you take a look at the individual guidelines or tutorials more closely to see whether the materials are going to be useful for gleaning some information, whether in terms of underlying issues or in terms of countermeasures relevant to that site. And then you go ahead and list the resulting chapters in the HFIM. And so for, again, this relates to the example that we'll talk through earlier, but for this example, we used keywords like medians and younger drivers and lighting, rural driving, speeding and speeding behaviors, impaired driving, to put together a list of, I think it's 8 or 10 guidelines across 5 chapters that could potentially be useful to this example. And so we've identified those individual guidelines, and these are ones that are currently in the HFG, and you kind of get a flavor here of some of the chapters and topics that are in the HFG. And then we go ahead and add those chapters to our HFIM just to keep it up to date. So the next step is to really go through, and you've identified some pieces of the HFG that could be relevant, and you're actually going through and doing some of the detailed reading. You're reading the chapters, maybe you're checking on some of the citations, you're working through some of the discussion, you're looking at trade-offs. And for each of those safety issues or risks, you start listing, well, what are some relevant road user needs or capabilities? What are some potential perception or performance issues that I see that could be going on at this site based on what I'm seeing in the HFG? What are the specific HFG recommendations or countermeasures? So the HFG is a mix of guidelines that have specific countermeasures as well as guidelines that just talk more broadly about issues. But there really is a focus in the HFG on solutions, on what you do, as opposed to just kind of talking through issues. And then the other thing is that you can be listing relevant data sources or research studies that could help support specific design changes or enhancements. A couple of things to think about as you're using the HFG. Every guideline in the HFG has a cross-reference section. And so if there may be some useful guidelines that you didn't pick up in your initial scan that could be useful, and so cross-references are important information elements in the HFG. There's also a set of tutorials in the HFG, and we use tutorials as a way of providing more detailed information on important topics that don't fit neatly into that two-page format that we use in the HFG. So there's some helpful tutorials in the HFG. Also, you want to be considering trade-offs related to design and road user performance. I mean, at the end of the day, design is all about trade-offs. We can't always do everything we would like to do. And the HFG provides a lot of information in terms of helping to understand some of those trade-offs from a driver performance perspective. And then the other thing to think about is whether or not differences between the as-built roadway, the roadway that you've got, and the HFG recommendations are, in a practical way, really likely to result in safety improvements. And so, the HFG doesn't sort of dictate, you have to do, X or Y or Z. It's really presenting the best available information from the research environment, but it's really, at the end of the day, up to you to make some determinations as to whether differences between the existing environment and recommendations are likely to be resulting in any kind of safety improvements, and what the real feasibility of those recommendations might be. And so this is just, again, an example of a little table that walks through we've identified those sections or guidelines in the HFG, and it kind of is a place to summarize, well, what did you find in this? What does the guideline really talk about? What are some pieces of the guideline that might be particularly useful to this study, or recommendations that might be useful? So this is just a way and a place to document your review of the HFG. Okay, so I'm going to turn now to the HSM, and then we'll walk through an example. And I'm going to go through the HSM pretty quickly. As I mentioned, I am not an HSM expert. It sounds like from our earlier poll, like most of you are, so I'll go through this pretty quickly. So the HSM was updated in 2014 after a 2010 initial release. And there are 4 parts. The introduction that also has a chapter on human factors that could be useful. The roadway safety management piece, which is mostly a planning piece. And then Part C, the predictive method, and Part D, the crash modification factors portion. And it's really those latter 2 that we'll be mostly focusing on today. So there are two tools that we use primarily in the HSM. The predictive method, which estimates crash frequency as a function of traffic volume and roadway geometry. The predictive method, it really provides a series of safety performance functions that are regression models that use traffic volume and other site criteria to predict crash frequency. And there's a few things that you need to have. You need to have the data on the roadway and the location, number of lanes, posted speed. You also need traffic volume, crash history data, and then a local calibration factor that's really important to utilizing the HSM. And Part C covers a variety of roadways, the rural two-lane, two-way roads, the rural multi-lane highways, and then arterials, both suburban and urban arterials. And there's lots of helps in the HSM. If you haven't already gone there, if you just Google Highway Safety Manual, there's a great website with all kinds of explanation and tools that are useful. So the second piece that we're going to use of the HSM is Part D, which is the crash modification piece. And crash modification factors is a multiplicative factor that helps estimate the change in crash frequency associated with implementing a particular treatment or a particular countermeasure. So if you wind up with a CMF of less than 1, then you would expect a reduction in crash frequency. And this also requires the crash history data and some general information about the roadway. The CMFs, the best place to get the CMFs is in the CMF clearinghouse. I think there are some in the HSM itself, but the CMF clearinghouse, and the website is right there, provides just thousands of different kinds of crash modification factors for different sorts of treatments. And it's very important when you go to the CMF, you kind of do searches on treatments that you're looking for, and a series of studies comes up. It's very important that you pick a crash modification factor that matches the crash type and severity of the situation you're looking at. So very often you'll have a particular treatment that has been examined under a variety of circumstances, and you want to make sure that the circumstances in which the research was done is as close a match as possible to the situation that you're in. Also, of course, you want CMFs that come from high-quality studies. You'll note that they've got a star rating that they use to indicate the quality of the CMFs. I think that the HSM has a bar of 3. I think they don't include anything that's less than 3 stars. But being able to judge the quality and include the quality of the studies in your recommendations is always going to be helpful. And as you apply CMFs, you apply them, multiple treatments are determined through a multiplicative approach where you're multiplying out the CMFs. And there's a recommendation that you not link together more than 3 treatments at a time for the purposes of figuring out that overall crash reduction. Jamie, I think you're up.
Perfect, thank you. And it does look like we have a few questions in the chat pod for you, John. I am going to move over to the poll break first, ask everyone about this. From what John just went through, which is not a step in incorporating both the HFG and HSM into a diagnostic assessment and countermeasure identification? Is it to collect site data, to conduct a road safety audit, to review site and existing conditions, to identify potential countermeasures, to develop and prioritize countermeasures, or to conduct safety effectiveness assessments? We'll give everyone a few minutes or a few seconds rather, to go ahead and fill that out. And again, at this point, if anyone has additional questions, please put them in the chat pod on the left-hand side. Does look like just about everyone's finished. Do have some people changing their answers, so I'll give you a couple more seconds. I have now closed that poll and broadcast the results for you, so you should be able to see them now.
So most everybody got that right, and those that didn't came pretty close. So conducting a road safety audit is not part of the HFG, HSM, although there's some overlap between what we're doing in road safety audits. But conducting a safety effectiveness assessment is a pretty good answer because even though that's technically part of the primer, we don't really talk about it in any more detail. In fact, I think that all the information we provide was on that slide that I had earlier. So those are all good answers. And do we have any questions?
No, I was incorrect. I was seeing the question from the last section. So I'm going to move you back to the presentation. And again, if anyone does have questions, you can put those in the chat pod at any time. We do have one more question and answer period, which we will stop for. So you can go ahead and put those in at any time while John is speaking. You're all set, John.
Thank you. So now we're just going to walk through an example that tries to tie together all the things that we've been talking about. And this is a rural multi-lane highway example. And it's example 3.2 because this is in section 3 of the primer, and it's the second example. So I mentioned that we have 5 examples total in the primer, and we tried to pick examples that represented the range of issues and crash locations and driving situations that designers and planners are going to be dealing with. And this is the one for the rural multi-lane highways. And this is the one where the handout that we've got over on the side is going to be particularly useful. The handout kind of walks through the key tables and worksheets that we used in developing this example. And you'll probably get a lot more out of using the handout than looking at the slides, which can present a lot of information in kind of a dense form. But the setup for this is the same as what we've been doing. Here again is the overall process for joint use, the steps and sub-steps. Those don't change. But the problem statement here is we're in a rural environment, and a new campus, a local community college, is planning to open a satellite campus in a rural section of a neighboring county. And the campus is expected to increase traffic volumes. And again, the setup is that in anticipation of the added traffic, the state DOT is looking at evaluating the safety of the highway south of the exit for the new campus. And so the new campus is right there. It's hard to see with that little green square, exit 145 there. And they're interested in implementing some improvements along about a 2.5-mile segment. And the DOT is looking in particular at adding corridor lighting as well as increasing the shoulder width to 10 feet. And so there's some additional countermeasures that the DOT is open to, but they particularly want to look at the contributions of an increased shoulder width and additional lighting. So these are some characteristics of the site. You've got 12-foot lanes, 4-foot shoulders currently, no lighting, no medians, no roadside barriers. You've got 75 miles per hour posted speed limit. Remember, this is the example that you've seen a little bit of detail from in my earlier slides. You've got a 2-inch drop-off between the traveled way and the shoulders. There's no access points within that 2.5-mile study segment. There's no particular curvature to worry about. There are some shoulder strips to the left and right of travel lanes in either direction. So that's kind of the basic setup. And here's some data on crashes. And so you've got 185 total crashes, 11 fatals across 5 years. Not a huge amount of difference across the different years or in terms of the breakout of fatals versus injury versus PDOs, but 185 crashes. And then here's some interesting stuff. This is the collision type by severity, and you see that out of those 185, most of them are roadway departures with some rear end and side swipe crashes as well. There's some animal strikes and some head-on collisions kind of rounding things out. And in terms of contributing factors, again, a mix of factors. The cross median was determined to be a contributing factor across a great many of them. And you have more contributing factors, of course, than you do crashes because there's some interactions going on. There were some alcohol issues, some distracted driving issues following too closely. Many of the crashes occurred at night, and there were a number of them that involved exceeding the speed limit. So from a human factors perspective, we'll deal with the human factors piece first and then go through the HSM. You're reviewing the relevant data, you're identifying those individual road user and vehicle factors, and then looking for interactions, things that could be contributing to road user confusion, errors, high workload, or distraction. And so in terms of this example, the crash data and the description that we just walked through provide some good cues regarding some potential human factors issues. In particular, the high speed limit combined with no lighting at all are very likely contributing to some of the lane excursions. Also, there's little in the way of roadside safety devices once those lane excursions take place. There's no cable or barrier in the median to prevent vehicles from crashing. One potential issue on the highway is the presence of oncoming headlamps, and so there were some head-on collisions. But oncoming headlamps could lead to some discomfort or even some disabling glare that could interfere with steering performance, and they could lead to some runoff road crashes or the head-on collisions. So that's kind of the qualitative look at the human factors piece. And so again, these are the same questions that we looked at earlier. We want to be asking ourselves, what's the nature of the crashes? What could those common crash types tell us about the relative contribution of the road user or the vehicle or the environment? What might be some sources of confusion? What are some unique issues associated with vehicle type? Are there maybe any misleading cues between the environment and the road user? And again, this is the one that we saw earlier. This is the partially completed interaction matrix, and this probably makes more sense now that you've seen a bit more about the crash site that we're looking at. But from the road user, we've got speeding behaviors, we've got some impairments due to alcohol, and then something to think about is that future increase in younger drivers. Remember that there's going to be an expansion of the college at that site, and so many of the additional vehicles that we're going to see are going to be driven by younger drivers. From the vehicle perspective, there's nothing that we know of for sure, but there's the potential at least for oncoming headlamp glare. Remember that it's fine at this stage in the process to be speculative, and the idea is to be overly inclusive in terms of factors in their interactions. From the environment, we've been talking about them: no barriers, no lighting, high posted speed, and then those increased traffic volumes. And then we've got the interactions, again, things that we talked about earlier: the lack of barriers combined with the high speeds, the lack of lighting combined with high speeds and maybe increases in perception reaction time. And then the speed limits may be too high for conditions, especially with the younger drivers. So from the HSM perspective, we'll kind of shift. We're at the beginning of step 3. This is just the base condition from the HSM, and it's using the worksheets that are available for the HSM. This is some inputs in terms of proposed conditions, and you see that we've added the roadway lighting, so it's present now, and the shoulder width has been increased. And then this is the results that you get using just the predictive method. This is just part C in terms of the crashes from the base condition and the crashes as a function of the proposed changes to the roadway, just the lighting and the shoulder width. And you see that there's a reduction in the expected crash rate. So there's other countermeasures that could be included with the HSM, and so we also want to take a look at those. There's different median barriers, there's installing a safety edge, and there's kind of doing both a combination of the median barrier and increasing the shoulder width. So for that, we're going into Part D, and we're using crash modification factors, and this table shows you the results of applying those different CMFs along with the standard error, the actual CMF itself, and then the high and low estimates forward, and then changes in crashes. And all of these are examples that we worked through for this. So then on the HFG side, recall that what we're doing is using some keywords to pull out those guidelines and chapters that could be potentially relevant. And again, now that you've seen the example, hopefully these make a little bit more sense. But based on the things like medians and younger drivers and lighting and rural driving and speeding, there are, I'll count them up again, there are 8 guidelines that could be potentially useful. There's some information in the curves chapter and in terms of improving pavement delineation and putting signs on horizontal curves, some issues on driver alertness on long tangent sections, a couple of topics on speeding, in particular setting and communicating appropriate speed limits. There's some guidance on post-mounted delineators, and then also some guidelines for lighting, including countermeasures for mitigating headlamp glare. There are really quite a lot from the HFG that could be relevant. So what we do in this step is just add those individual guidelines and chapters to the table. And then you'll recall that the idea is to actually go in, read through those guidelines. Each page is only 2 pages, and so for this example, once you've done some of your setup, you've only got 15, 16 pages to read for the whole exercise. But the idea is to pull through each of those guidelines and try to get a sense of what it really presents, what information it presents, what kind of guidance might be most useful for that particular example. And then in step 4, this is little text. I apologize for that, but it is in your handout. I think on the last page. What we've done in the primer is we've used color coding to indicate really the level of desirability of individual countermeasures. So we've used green to indicate ones that are probably higher priority, yellow to indicate ones that could potentially be looked at, and then I think we've just kept it as white, the background, for ones that we think should not be looked at. There are none of those here. But what we've tried to do is indicate the source of the potential countermeasure and then try to discuss it with reference to the analyses that we've just done. And the issues are, well, how well supported is a particular countermeasure in terms of the HFG presentation, in terms of the HSM presentation? What do we learn about feasibility or cost or trade-offs from either of those? To what extent do you have guidance or recommendations from both of the sources, and what does that tell you about the desirability of an individual countermeasure? And so we're just using, again, a table to kind of walk through some of the pros and cons of individual countermeasures as they relate to what we've learned from the HFG and the HSM. And then finally, in step 5, this is sort of our standard. You need to do some kind of before and after assessment to determine whether or not the countermeasures are actually having their intended effect. I think, Jamie, you're on now. And I think Jamie, that mostly concludes what I had to say, other than a little bit of wrap-up.
Correct. And it looks like at this point we do not have any more questions, so one more time I'll let everyone know there's a chat pod on the left-hand side. Any final questions you may have for John, you can put in there at this time. I do have one more poll break for everybody. And the question is, how do you feel about the Human Factors Guide Highway Safety Manual primer? How do you feel it will be useful to your organization? Yes, no, not applicable. And we do have a few wrap-up slides, as John mentioned, after this poll question. But again, if anyone has any questions for John, on the left-hand side is the chat pod. Okay, and John, it does look like about 90% of the people feel like it will be very useful to their organization, and about 6.5% said it's not applicable to their organization as well.
Well, I'm really pleased that people think they're going to get some value out of it. That's what we've been trying to do, and all I can say is I hope it'll be published in the next 6 months or so. I think, Jamie, we can send out a note and a link to everyone who's signed in today once we have that information, correct?
Absolutely. Absolutely.
Yeah.
So in about a week, you will get an email from us that has the link for the recording of today's webinar, which will also have all 3 of the handouts available at that same link. And then once the primer is published, we will again send an email out to that same listserv to let you know that it has been published, and we'll update the this recording as well to post that there too. Okay, it looks like we do not have any additional questions for you, John, so I'm going to go through a few more of these slides. A lot of the resources that John spoke about earlier can be found online, and we have put them all on this one slide. Again, this is available in the handout section in the bottom left. There is a PDF of these slides. If you're interested in these, you can download that now, or it will be available on our website as well. And so those are for the 2nd edition of the Human Factors Guide, a link for the Highway Safety Manual, and a link to the Crash Modification Clearinghouse. Again, as John just said, when the primer is available, we will send that out to you via email. In today's webinar, we hope that you guys learned to summarize the role of human factors in roadway design, operations, and safety, to incorporate the Human Factors Guide and the Highway Safety Manual into the data-driven decision-making process, and also to illustrate how to use both of those guides together to improve decision making. A couple of notes for everyone listening today. We have our next 2 webinars have been scheduled. The next one will be creating a rural transportation planning organization. That will be held on Tuesday, March 20th at the same time. And then the one in April will be sharing the road with slow-moving vehicles, held Thursday, April 26th. That one will go through all kinds of slow-moving vehicles, including agriculture, bicycles, horse and buggy, and then also vehicles that are being used in a parade and funeral procession as well. So please sign up for those if you're interested. As always, you can find all of our webinars archived on our website on the archive training page. And I do want to thank John one more time for speaking today. We really do appreciate you taking the time out to do this, and it does sound like from the beginning, when most people hadn't heard of the Human Factors Guide, to the end when everyone thinks it will be very useful, that our audience definitely got a lot out of your talk today. So we do appreciate you speaking for us.
Well, thanks to you, Jamie, and to your team, and thanks to all of you for taking the time to dial in and for your attendance. Your attention. I appreciate it.
If anyone has any additional questions for John, his email address is on the screen right now, and that is it for today. So thank you, everybody.